America is preparing to spend up to $15 billion on a single bridge. But this isn't just another infrastructure project. This crossing has become one of the biggest bottlenecks on the U.S. East Coast. Engineers are now planning one of the most ambitious bridge replacements in America's history. This is the Chesapeake Bay Bridge.
That have taken place on the Bay Bridge Tunnel.
Wider and taller Chesapeake Bay Bridge is closer to reality tonight.
The American East Coast is a powerhouse of global commerce, a continuous corridor of cities, ports, and industries, stretching from the skyscrapers of Manhattan to the sunshine of Florida. But for decades, this massive economic engine has been choked by a single 4-mile stretch of aging concrete and steel, the Chesapeake Bay Bridge. By 2025, the existing spans had become more than just a bad commute. They were a national liability. With over 27 million vehicles crossing annually, the dual structures, one dating back to 1952, were pushing past their absolute engineering limits. These traffic delays weren't just costing commuters their sanity. They were draining the regional economy of an estimated $2 billion every year in lost productivity and fuel. That is a staggering amount of waste. But as of early 2026, the United States has finally pivoted from patchwork repairs to a generational solution. The Maryland Transportation Authority, MDTA, has officially greenlit Alternative C, a massive $15 billion to $17 billion planned to replace the entire crossing. Now, we aren't just talking about adding a third span anymore. We are talking about building 2 brand new 4-lane megastructures and the total removal of the historic bridges we see today. This is a story of a solution whose scale dwarfs every previous proposal, a dual-span hybrid designed to fix the Atlantic corridor for the next century. Please take a moment to subscribe and like the video. It really helps the channel. Building a mega bridge across the Chesapeake is an exercise in wrestling with physics and geology. The bay is a beautiful, shallow estuary, but beneath its surface lies a nightmare for civil engineers. A thick, treacherous layer of Chesapeake silt. This soft, shifting sediment offers almost zero structural support. To find bedrock or even stable, stiff clay layers, engineers have to drive piles deeper than almost any other bridge project in North America. The existing bridges are already feeling the strain of these shifting foundations, requiring constant multi-million-dollar deck replacements just to keep lanes open. The 2026 plan ditches the traditional suspension and cantilever designs of the 20th century. Instead, it moves toward high-tensile cable-stayed towers. These soaring pylons aren't just an aesthetic choice. They are designed with a much lower center of gravity and a wind-shedding profile. That's critical for withstanding the hurricane-force winds that are becoming more frequent along the Atlantic coast. But the real engineering hurdle isn't just holding the bridge up. It's keeping the world moving underneath it. The Chesapeake is home to the Port of Baltimore, one of the most vital maritime hubs on the planet. Following the tragic collapse of the Francis Scott Key Bridge in 2024.
Francis Scott Key Bridge collapse in Baltimore.
6 men who died were working on the bridge when it collapsed.
The new Bay Bridge has been redesigned with safety and clearance as its primary mandates. The new design calls for a vertical clearance of 230 feet. That's a significant jump from the current 186 feet, roughly the height of a 20-story building. It's specifically calculated to allow the world's largest Neo-Panamax container ships to glide underneath without a centimeter to spare. However, achieving that height creates a massive problem: the Incline Dilemma. To get a bridge 230 feet into the air, you need miles of approach ramps. That consumes valuable land and creates steep grades for heavy freight trucks. It's a logistical headache. To solve this, the $15 billion plan incorporates a bridge-tunnel hybrid. In the middle of the bay, where the primary shipping channels run, the road doesn't go over the water. It dives under it. Using massive custom-built tunnel boring machines, TBMs, the largest ever deployed in the U.S., crews will carve twin paths through the earth beneath the navigation channels. This deep channel approach eliminates the need for a sky-high bridge deck that would be vulnerable to high winds and vessel strikes. To make this transition, engineers are using the island transition technique. This involves building massive, man-made land masses in the center of the bay. Artificial islands that act as the portal where the soaring aerial spans descend into the subterranean tunnels. It is a feat of precision synchronization, marrying a flexible, wind-vibrated bridge to a rigid underwater concrete tunnel requires a level of structural modeling that simply wasn't possible a decade ago. Every millimeter of thermal expansion and seismic shift is accounted for using digital twin technology, ensuring the transition is seamless for the 90,000 vehicles expected to use the crossing every day. A project of this magnitude requires more than just steel and concrete. It requires a revolutionary financial engine. The $15 billion to $17 billion price tag is being met through a sophisticated infrastructure-as-a-service model. While a large portion comes from federal infrastructure grants, a significant chunk is fueled by private sector technological partnerships. This isn't just a dumb slab of asphalt. This is the world's first truly cognitive bridge. Integrated directly into the concrete foundations are tens of thousands of real-time structural health monitoring sensors. These sensors provide a constant stream of data to a central AI, predicting maintenance needs years before a crack even forms. This predictive maintenance model is expected to save the state over $500 million in long-term operational costs. Furthermore, the bridge features smart tolling and dedicated lanes for autonomous freight convoys.
Tolling systems launches next week on the Chesapeake Bay Bridge. This morning, the Maryland Transportation Authority.
By 2026, the speed of manufacturing has also been revolutionized. Rather than pouring all the concrete on site, the project uses advanced modular construction. Entire sections of the bridge deck are being prefabricated in indoor facilities and barged into place, allowing for 24/7 construction regardless of the weather in the bay. This has allowed the MDTA to squeeze a 15-year project timeline into just under a decade, with major construction set to hit full stride by the late 2020s. You cannot talk about Maryland's infrastructure in 2026 without talking about the key bridge effect. After the 2024 disaster in Baltimore, the public and political appetite for bridge safety changed forever. The $15 billion plan includes a $175 million pier protection package that is being installed even before the new spans are completed. This includes dolphins, massive circular steel and concrete bumpers anchored to the seabed, and fenders that can deflect a 100,000-ton vessel away from the bridge's critical supports. The new dual-span design also solves a major safety flaw of the current bridge: the lack of shoulders. The old spans were so narrow that a single flat tire could paralyze the entire eastern seaboard for hours. The new 2026 design features full-width safety shoulders on both sides of the 4-lane spans, ensuring that emergency vehicles can move even during peak holiday traffic. When the final span is placed, this mega structure will be the crown jewel of America's modern transit network. By eliminating the East Coast's greatest bottleneck, the bridge will slash idle times, drastically reducing carbon emissions from the millions of tons of freight that previously sat in gridlock. But more than that, it represents a shift in American ambition. For the first part of the 21st century, the story of U.S. infrastructure was one of fix it first, essentially just trying to keep the lights on. But here, in the middle of the Chesapeake, we are seeing the return of the big build. This $15 billion gamble is a blueprint. It proves that by combining hybrid engineering, smart city technology, and modular manufacturing, we can build structures that aren't just bigger. They're smarter, safer, and ready for the next 100 years of commerce. The Atlantic Corridor is finally opening up, and the world is watching to see if this Chesapeake model will be the spark that reignites architectural ambition across the entire United States.